last December. So that's why we're so sparkly clean. So Oak Lodge Sanitary District, we have responsibility in Oak Grove and Jennings Lodge, parts of Milwaukee and Gladstone for sewage treatment and conveyance, surface water management, industrial pretreatment, and then permitting and all that kind of stuff. And we have a whopping 24 people in the district to do all that stuff. So you won't see a lot of people as we do this tour because everybody's running around. So for on the collection system side, we've got about 100 miles of collection system we maintain. And so we've got a TV truck. And if I was thinking, I would have had someone open that up. But
I can do that.
so yeah, so we have a TV truck. It's got its full complement of video equipment. So we have remote video. I don't know if you guys have studied that, but we do. Yeah, it's kind of back there in the corner. We do video inspection of all the sewer lines. To check for structural defects. Most of the time, what we're seeing is root intrusions, cracks in the lines from time. A lot of the system was installed in the 60s, so it's pushing 50, 60 years old in some cases. What you see here is a Vector, hand-me-down from Clackamas County.
Vector truck here.
We can use it for hydro cleaning lines, as well as vectoring out debris in the sewers, potholing for utilities, stuff like that. And then in this spot here is where our flusher truck goes, and they're out cleaning lines right now.
What truck? I'm sorry.
Flusher truck, hydro flusher. Aquatech. So it has the sewer nozzles that run at about 1,500 psi.
1,500 psi for the sewer truck.
So that's where it all starts, and then so from out in the district, we have 5 remote pump stations that help the sewage get here. But what you see there on the pad,
5 pump stations.
That's our influent pump station. There's 2 wet wells, and we can kind of cruise over there.
Okay, starting in the treatment process of the headline.
Wastewater comes in actually
2 wet wells.
From that side and comes in this way. We have 2 wet wells. Like I said, it's about 40 feet deep. They made it deep so that the collection system would drain better. The old pump station wasn't as deep, and so then when we had high rain events, it would back up and then overflow into the river, people's houses, and all that kind of stuff. So they dropped it down quite a bit so they wouldn't do that. Capacity at the facility. We've got about 20 MGD capacity for rain events. Our design flow is only like 4.3 MGD. So, you know, we'll see on a typical rain event anywhere from 17, 18 MGD on a pretty good rain event. Hasn't been raining much lately. So
4.3.
Yeah, pretty much.
That's average.
Yeah.
What is it today?
Oh, I'd probably say about 3.
Quite a bit lower right now, yeah.
Yeah, we haven't had a lot of rain. So the good news is I budget a lot of money for rain and power.
So you're saving some money right now.
Saving a lot of money right now. So speaking of power, any questions on the pump station? Submersible pumps, so they're down in the soup. Got 4 or 5 MGD pumps and a 3 MGD pump for the lower flow period.
How often do you have to derag them?
As far as deragging on these pumps, we have not had to derag them. They're sewage pumps with open vein impeller, so they will pass a 4 or 5 inch solid. What we have had issues with, the system's offline, otherwise I'd show it to you, but we have had issues with scum buildup. So this particular structure is designed for like 32 MGD. So at a flow rate of 3 MGD, this acts like a primary clarifier / grit removal system, and everything settles down. So what we installed was a device called a Gamma Jet, and it's used in the food industry for cleaning vessels. and it's a stainless steel nozzle that works on low pressure, high volume, and creates high pressure through its nozzles, and it spins. We found it on YouTube. So it spins in like a 360-degree radius. So they use it for cleaning vessels in the food processing industry. Someone started using it for remote pump stations, for cleaning pump station scum and stuff like that. So we saw that, and we actually had one designed for this pump station, and it doesn't clean 360, it cleans 180 degrees, but it shoots this probably about an inch diameter water jet into the soup and keeps everything all churned up, and it does that at the cost of about 80 GPM, so it's pretty low in the grand scheme of things. But it's offline, contraption broke, so we're getting it fixed. So from there, the flow is pumped up there, and we'll to the headworks, and we'll go up there. I just wanted to point out that brown structure, or green, depending on your color profile, is a
green structure.
A generator.
Or brown.
So
generator.
It's like
generator.
It's a 2.3 gigawatt.
2.3 gigawatt.
Yeah, I guess it's a gigawatt. I just first thing giga. Who knows?
That's good.
Anyway,
big one.
It's unique in that I think Tri-Cities has one of these as well, but it's called dispatchable power.
Dispatchable
So
power.
what we do is we get into an agreement with the power provider, which is PGE, and so they maintain that emergency generator with the agreement that if they need it out on the grid, they can use it, but we get priority. So if there's an emergency, we have a power outage, whatever, we can use that system, but because they're able to use it as a dispatchable source of additional power, they paid for half of it, and then they maintain it and control it and do all that. So it's good for us because we don't have to maintain a generator, which can be quite a challenge sometimes. So it's a great big giant Caterpillar engine. Kind of I guess another cool thing about that is if it was running right now, I'd be talking at the same volume. You can't even hear it run. You have to actually look at the stack and see if the little flappers are on. Yeah, so it's very, very friendly for the neighbors. So we'll walk up there and I'll show you the bar screen.
Bar screen going to the headworks now, green flow here.
The flow comes up into this channel here. It is distributed about these 3 channels. This is our main bar screen. Trying to never use this. Then we have 2 automatic input bar screens. What makes these unique, I think, is that they're actually bar screens. I don't know how many of the plants that you guys have been to, but most of the larger facilities still use bar screens. I should say a lot of them are actually even going to the perforated plate. Actually where they just have a plate with like 1/4-inch holes in it. Nice thing about bar screens is that they're actually bars and they're very easy to maintain. I think maybe some of the facilities you've gone to, they have like the basket screens and all kinds of different things. Yeah, so they all fit their niche, but I guess here, again, the nice thing is that basically all we have is a motor, a gear, a chain, and that's it. So it's nice for maintenance, extremely reliable. So next thing, it's kind of hard to see here, but so the bar screen comes up, discharges the solids down into this channel. This channel is actually controlled by water. So again, no mechanical things to have to try to maintain. When this screen comes on, flush water comes in, flushes it to the bottom, to the end of the channel here. And then when we get downstairs, you'll see the solids take about a 40-foot plunge into the compactor. So we'll take a look at that. It's all hydraulic to this point. And then from there it goes to the grit channels. The grit channels are unique in that they're called head cells, and The reason they're different is that they kind of have kind of stacked, if you will, funnels that have a small angle of drop. So they're about the diameter of each. There's 2 head cells in there, and they're about the diameter of that square. So 14, 15-foot diameter, and there's about 15 plates, all with kind of a funnel hole in the middle. So the idea is that rather than have a bunch of surface area to create this quiescent environment to get the grit to settle, we do it vertically in a bunch of panels. So the idea is that all the grit falls down, and it creates, the way it shoots in there, it's creating a circle, and then all the grit kind of falls on a table and down through the hole. So kind of unique. More and more systems are going that way, as opposed to the kind of the pista grit, some of those older technologies. So from there, goes downstairs. We'll take a look at the grit pumps. But the grit pumps actually pump up to the system that you see over here. They're about 180 GPM.
Grit pumps right here.
It goes through another hydrocyclone up here to further remove organics, so that everything that falls down onto the classifier is essentially just a real fine grit. Good news, bad news on that is that the old plant had primary clarifiers. So primary clarifiers are good because they take out that initial dose of food, real inexpensive. Here we don't have them. So what happens is that we get rid of the real fine sand, but they're still organics that end up in our aeration basins and settle out. So we've had to kind of fine tune the system so that we get a little more of the inorganics than just the sand. But this system is so efficient that if all we wanted to get out was the real fine sand, this could do it. Again, there's more inorganics than sand. Corn comes to mind, but anyway. So that's our grit system. Questions on the grit system?
So what is that like spinning in? Is that the actual stream, or is that something?
So that's the blowout from the grit. The grit flows up here and spins, and then
spins.
What you see going down there is going down into the classifier. So it's kind of there's a couple of different venturis in there, so that it kind of all the solids kind of go against the wall, and the water goes down the center. So kind of hard to see. We'll get some more pictures up here to see that. But the gist of it is it's very efficient. And again, for us, it's almost too efficient. So when we go downstairs, you'll kind of see the grit. We get rice, stuff like that. Whereas when we first started the system up, literally all we were getting was real fine sand. This system is part of the cannibal process. I'll just talk a little bit about it. So you'll all be getting in the business at some point with any luck, right? So one of the things you'll find out is even with the brand new plant, you have equipment problems. So that's why this is offline right now. With this, I'm still figuring out my tour process, but try to figure out where to put everything. But this system ends up in a dumpster downstairs and then goes to the landfill.
Part of the cannibal system here.
As far as the cannibal process goes, and Darren will get into kind of the process specifics, but the idea behind the cannibal process is that instead of generating solids from treating wastewater, we were trying to reduce solids. So a typical wastewater plant, for every pound of BOD you bring in, you generate a pound of waste. And that waste has to be digested and dealt with. With the cannibal system, what they try to do is get it to where for every pound of BOD you bring in, you generate 0.1 to 0.2 pounds. So whereas if we had 10 trucks leaving, going up the hill, burning fuel and disturbing the neighbors, now we only have one truck. So as part of that, as it gets through all these systems and grid systems and screens. The solids still have, you can kind of see it up here, it's kind of a pulpy, papery product, and that's in the activated sludge. That's made it through the screens, the grit removal, and so what we're trying to do is that material won't degrade. So we try to remove it. It ends up, like I said, like a pulpy paper mixture. And this screen's usually running, trickling, and creating kind of these baguette-sized little rolls that end up down in there. And then the reason it's offline is that the screw press down there that compresses it is offline. And kind of a little aside is that have you guys seen like compactors and stuff during your tours? Screenings, compactors. So the screens go into a chamber and then they're compacted as they go out. We'll take a look downstairs if you haven't seen one. But the issue with this particular unit is that when a product is made solid, and it could be screenings or this product here, after it's been compressed in the compressing zone, when it comes out into the chute that discharges it, it tends to expand. And so in our case, the tube was coming around at a 90-degree angle, and that was causing friction. And then along with the expansion of the product as it came out, it was creating more friction. And then ultimately the screw press was stronger than anything else, and it ended up kind of breaking in several places. Is kind of the end of the day. So we're sorting all that out with the manufacturer, but that's why this is offline. But it's about 20% of when Darren talks about the yield, and the yield, when we talk about yield, the yield is how many pounds of BOD are you producing and waste, how much waste are you producing for every pound of BOD that you treat. So in the case of some of these utilities that are treating fats, oils, and greases with their anaerobic digester, and they have primary clarifying. The more solids you get, the better, because you're going to be able to produce. You're going to be able to run your cogen, produce power, and all that. But we don't have any of that, so we want to get rid of it. We're getting. I think the key to the cannibal is you can get rid of it biologically. Okay, and then so 80% of it's biological, and then 20% is actually mechanically getting rid of the inorganics.
The flow here.
If you look out over on the other side of the IPS, you see a couple of square units there. That's our biofilter.
Odor control.
Bark dust. It treats all the odors that are generated at the facility, with the exception of the old plant. Darren will tell you all about that. I won't get too caught up in this. But kind of a couple side benefits to the longer SRT that we're able to see, and that you're seeing here, is that we're able to remove ammonia. And so we get about 27 milligrams per liter of ammonia into the facility, and we discharge 0. And it's not in our permit, so it's just kind of I'd like to take an environmental steward credit for that, but it's really a function of the SRT. Longer SRT that you guys have in your facilities, you start to build organisms that will reduce the ammonia, nitrifiers. So once we get that going, we start nitrifying here in the Willamette Valley. Whether you guys go in water or wastewater, alkalinity is a big deal. Alkalinity in the waters in the valley is very low. And so here at this facility, when we're nitrifying, we lose our pH and alkalinity because of nitrification. So what the engineers designed for us was this ability to go into an anoxic mode. So what we do is at the end of the train, there's 3 pumps that pump the mixed liquor back up here. And so once we've nitrified, we have a bunch of nitrate. And so what the bugs are able to do, instead of using oxygen, they use nitrate as their source. That's what they're doing in here, and that's what you're seeing here. So there's no oxygen in here, but the bugs are using nitrate as their oxygen source. And what else? It keeps filaments from growing.
The duck just went into the scum trough. Look, he was stuck in there. Sorry.
Oh, that's all right. We have casualties here. Last Friday, at the end of the day, one of our guys responded to a call of 8 ducklings going into a catch basin.
Oh, no.
So we did it all. And he saved them and told the lady not to put her cracked corn around the grating.
Oh, yeah.
So this is good stuff. We don't get filaments. Again, Darren will go into detail about the process evolution from the old plant to this one, which is huge. But so day in, day out, we're nitrifying, denitrifying, creating a very good settling sludge, all a lot to do with having these anoxic zones. So you'll see when we go through here, there's 4 basins. We have 2 basins that are anoxic and 2 that are oxic.
2 anoxic, 2
typically
oxic.
anoxic basins are only about 20% of your volume. But here we're kind of stretching it a little bit because we can. And we have like 50-50.
Normally 20% anoxic, 80% oxic. Here it's 50-50.
So you're seeing mixers, slow speed mixers are mixing everything. We have ORP control, ORP monitoring that we use for process control and measuring how much detention time we want to keep in there. So you guys studying ORP at all?
Not yet, no.
Okay. So ORP I want to say it's new, but it's not anymore. It's very prevalent in the wastewater industry now, and I think even in the water industry they're starting to use it a lot more. But we've got them throughout this treatment plant now, which you would have never seen years ago. In the water or whatever product you're trying to measure.
Should have a little reading, and it gives you a
it's
feel
not
for whether you're
it's an operator's tool to kind of get where you're just watching for change. Because you could have an ORP of like 100 that might be good or bad in one industry, or you might have an ORP that's negative 200 and be good or bad in an industry. So like on this side of the fence, on the wastewater side, a negative ORP represents no oxygen. So we really watch how far it goes. And again, Darren will talk to you about it, but it's really helpful for the operator. In the anoxic zone, when I talk about this mixed liquor recycle, when we're recycling the nitrates, we're returning 3 times the plant flow. So say if we're getting 4 times, or 4 MGD right now, we'd be recycling 12 MGD. So what you're seeing here would be, what, 16? Fine bubble aeration. So that in itself is like if you shake up a soda bottle, you're going to get the foam. Crack a beer and drop it, you're going to get foam. So some of it's caused by that. Some of it's grease. Sometimes you'll get a certain kind of filament that'll contribute to it'll float and cause grease. Sludge age will affect grease, the foam. Lower SRT, young sludge will get more foam. So this is pretty much what we see. So you go with the SRT. So like I say, we run about a 10 to 15 day SRT. And we probably have to spend more time, and we're still kind of learning about so those are our mixed liquor recycle pumps. They're vertical turbine pumps. Typically, though, we try to use vertical turbine pumps for these high volume, low head applications. So if I could give you any advice going into the industry, know as much as you can about pumps. That's all we do is pump stuff. But in this case here, as you can kind of tell, to get the water from there back over there is not a great elevation change. So what we fight with is the fact that when these pumps are pumping from down below up above, there's actually a negative suction head. So there's actually air pulling the water. And pumps don't like that. So that's why one of the pumps is out right now, is that we're having trouble with the pump pumping off its curve and cavitating and basically destroying the bearings and seals and shafts and all that. So as you can see, we've got a few kinks we're still working out with things. Those are all things you guys will see.
You guys rebuild your own pump too? You guys have a maintenance guy that
We have two maintenance guys. We kind of pick and choose what we rebuild. We had the factory rebuild those two, and we're rebuilding the third one. It kind of depends on workload and skill set. More important to get it done right. But, so the flow from the aeration basin is going to the 4 clarifiers you see here.
The 4 clarifiers.
Yeah, 2 clarifiers online now.
Clarifier, that one's offline. Offline. Bar one back there. 4
You guys see
clarifiers are online.
clarifiers? It's round and sucks off the bottom. It's not like scrapers or anything
No
like
scrapers
that.
on the clarifier.
So that's kind of a unique deal with those clarifiers. They're actually all 4 of them are secondary clarifiers here.
Yeah, there's no primary clarifier here.
Aerobic digester. I can show you some kind of performance upgrades that we have on our clarifiers. We could look at the belt press, gravity belt, neither of which are running right now. And then that structure over there is UV. So there's really not a lot to see there other
UV
than
over.
some channels with some sun lamp bulbs in the water. So I think what I'll do is we'll just cruise up here and I'll show you some of the clarifier performance enhancements and show you the aerobic digester.
Yeah, it's good to see the innards in one.
A lot of clarifiers that you guys will potentially go to won't have that Stanford baffle. Some of them won't. And actually what it does, but just for your point of reference, this is the interchange bioreactor.
Interchange bioreactor.
So everything you've seen on this side is kind of conventional, what we call conventional activated sludge. This interchange reactor is kind of the heart of the cannibal system. And it's kind of a cross between an activated sludge aeration basin and an anaerobic digester, but not quite either. There's 2 basins here. Each of them are holding right now about 50,000 pounds of product. And we had the blower fail on it this morning, so on a hot day.
Builds the suspense.
Potential odor, yeah. We got it fixed, or I should say we reset it. We just put it online last week. So we have an anaerobic digester over here. It's a remnant from the old plant.
Remnant from the old plant, the anaerobic digester.
Primary clarifiers in a high-rate activated sludge plant. We produced a lot of sludge and made it very compatible for having an anaerobic digester that could treat that high rate and then produce methane to operate the boiler, the heat of the digester, all that. So now that that's gone, because we won't be loading this very heavily. We used to load the anaerobic digester with 5,000 to 7,000 pounds a day of product. Our goal is to only load this with 1,000 pounds. So we're looking for a big shift. The reason we have this online right now is we're anticipating that shift, so we have to get this system biologically ready to take on that.
1 week old, this aerobic digester.
Any questions?
Where do the solids go that are in here?
Oh, good question. So where the solids go from here, so this is basically our solids processing. This is our digestion. This is where we will meet the 503 regs for ability to produce class B biosolids to put on farmers' fields. In the anaerobic digester, we were monitoring for temperature and volatile solids destruction. With this unit, we'll be doing the same thing with time and temperature, but instead of volatile solids reduction, we'll be monitoring the specific oxygen uptake rate. So basically, if we can show that there's no oxygen uptake rate, the solids are considered stable. So from here, it ends up going across the belt filter press. Have you all seen a belt filter press? All right. Seen one, seen them all.
What's this pit over here?
That's our second aerobic digester.
Oh, okay.
It's filled with water, otherwise I'd show you the pod. What you see here is the product of what they call a jet aeration system. So, believe it or not, the blower's on right now. A jet aeration system gives you the ability, basically there's a pod down there with ports in it, and so we can just mix, we can pump it, and you'll see the same mixture, or we can turn a blower on and it'll pump air into that same pod and oxygenate the wastewater product. Aside from the fine bubble diffusers, it's one of the most efficient ways to transfer oxygen in the sludge. Yeah, it would take a long time. We do let it get anoxic. We haven't got to that stage right now. Right now, we've been aerating this for 3 days and we haven't gotten the residual oxygen. Yeah, it's good. Yeah, it's this digester is 6 days old. So it's
6-day-old digester.
It smells good. Very low power consumption.
Not ozone, excuse me, UV.
This area right here
GPTs
used
are
to
in
be
here.
where we had our
Pumps
chlorine
for the aerobic
contact
digester.
station. We used to store up to 3 tons of chlorine on site, which was a pretty big deal.
Yeah.
I think we finally took our socks down. But, you know, chlorine's a real hazardous substance, especially in the liquid form. So we're really glad to get rid of that. So now we use UV, and it's working real well.
No chlorine at all?
We use hypochlorite for plant water. That's a good question. So yeah, we use plant water throughout the facility, and so yeah, we maintain about a 1 to 2 part per million sealed. Ops office, got our wet lab here. So I'll kind of see. I saw Kyle. I don't think there's anybody in here, so we won't be
On site and test.
Yeah, so good question. So we had a lab person here with the full-on. Actually, let's go sideways.
How dangerous is that to say that it's cooler inside in May? Oh, it is nice and cool. Okay, here we go. Muffle furnace. There's your desiccators. Yep. Got that.
God bless the man that didn't get over.
All right. So this is our lab. We basically do what I would call a glorified process lab in here. We don't do BOD or TSS for permit. We don't do any of the priority pollutant tests or anything like that in here. So basically we're just doing our daily process control tests, our permit pH, temperature, and stuff like that. At one point the district did have like a dedicated lab person here, but kind of made the business decision to put that resource somewhere else, and then it was more cost effective to pay, I think we're paying about $30,000 a year for contract lab services. So that's what you see here. I don't know that we'll all fit in here, but let's see. Have you guys seen the SCADA systems?
I've been kind of taking a quick peek, I think, yeah.
Some people may have not.
Yeah, so if you haven't seen the SCADA system, well, you can funnel through here, I guess.
Anybody not seen SCADA?
Yeah, it's cool.
Come on in, it doesn't bite. You can come on in.
So, and maybe you can all hear me in the lab, but we run the show here at the district from 7 to 3:30, maybe a little later today. But
Sorry about that.
so no worries. The ability, what allows us the ability to do that is that we have one operator on call from 3:30 till 7 in the morning. Must have a laptop at home, but they take a laptop home. Yeah. Here's usually it's here, but anyway, they take a laptop home and they can see exactly what we're seeing here. They basically gain control of this computer, and in doing so, get control of the plant. So, you know, there's a lot of small to medium facilities that are doing that. I think you guys said you went to Gresham. They do something similar there. So modern technology allows us to go home at 3:30. But basically, what the SCADA system does is it's kind of a monitoring control system of the whole entire facility. And in our case, we can actually even get remote access and control of our effluent or our remote pump stations. So it's a brand new system. So this system is monitoring the status of all the equipment that's online, the flow, the pressure, the hour meters, and then from this system, we also have a communication with our plant maintenance system that tells us, you know, we've got to maintain it at 100 hours, and this unit's now at 100 hours. It's time to do some maintenance. And then this system is also plugged into another software program that keeps all of our lab data. So the three systems kind of create a pyramid for the operators to control their maintenance, monitor process control, and have live feed on all the plant stuff.